All right, guys, we did reflections. We moved translations. We moved side to side. Reflections means we flipped up and down. We flipped side to side. And now we're going to do compressions and stretches. Now, the first type of compression and stretch we're going to do are our old favorite, the vertical compression. And the reason I say favorite is I want you to think of basic parabolas, y equals x squared. So the basic parabola y equals x squared is this one here. Okay, so I go like this. I plot my step pattern, use my step pattern. I plot my mirrored points, and I draw something like this. Okay, so that's my basic parabola. And now we're going to stretch it. And you would have told me before the class started that y equals 3x squared is a vertical stretch of 3. So your step pattern is tripled. So this, instead of being up 1, is up 3. And then the next one here, this point here, instead of being total up 1, 2, 3, 4, it'd be up 12. So it'd end up here somewhere. Okay, or you would say my step pattern is over 1 up 3, and then 3 times 3 is 9, so your next step is all the way up here. So that's that, and that's that mirrored point here and here, and you would have what we call a vertical stretch or a stretch of 3. Okay, so that was a horrible drawing, but what you notice is there's no bracket here. This is on front of the whole thing. It's not on the x, it's on the whole function, and it's vertical. If it's a half, you would have told me that my step pattern is over 1 up a half, over 1 up 3 times a half, which is 1 1/2. It gets me right here. So this is a vertical compression of a half. So you would come back and say, this one here is a vertical compression of a half. Okay, you wouldn't tell me it was a vertical compression of 2. You would say vertical compression of a half. And this guy here in purple is a vertical stretch of, what do we do, 3. Okay, so that's great. That's simple. You would have known that before. Now, instead of going vertically, this is where, just like before, we had reflected vertically or reflected in the x-axis, and then we had to figure out how do you reflect horizontally. It's the same sort of thing here. You have to figure out how do you stretch horizontally. Now, horizontal stretch is a lot like a vertical compression and vice versa. Okay, if I take this blue guy here and I pull it out, I end up on the red one. Okay, what I had done was pulled it down, so I'd vertically compress it, but it also could have been a stretch this way, which is what we call a horizontal stretch. So they do interact, but the difference is, algebraically at least, the difference is my multiple, my 3 or my half, is right on the x. So I have something like this, 3x all squared. So if I put that into an equation, or if I try to figure out what that is and put a table of values, or if I graphed it in Desmos, and why don't I do that? So miraculously, I'm in Desmos here, and you see, you can't tell here, but there's an orange and a blue. Let's see if I can shift this over. Can I shift this over? An orange and a blue. There we go. An orange and a blue parabola. So the blue one's x squared. This one, it looks like x squared, but what I'm going to do is throw this 3 in front of the x. Okay, so if I throw it in front of the x squared, like if I throw it here, what you're going to see is that's your vertical stretch. Okay, I get pulled up like that. But if I put it right on the x in a bracket, what you're going to see is something a little different, and it gets a little more narrow. Okay, so what happens is, don't think of this as being pulled up or down. Think of this as being pushed in now. This guy here, because it's on the x, it's a horizontal transformation, and it's a 3 here. So it's 3 times, but it's not 3 times. It's 1/3 as wide. So this orange guy is 1/3 as wide as this blue one. And what we call this is a horizontal compression of 1/3. So to figure out if it's a compression or a stretch horizontally, you look at the size of the number. If it's bigger than 1, then it is a horizontal compression. If it's smaller than 1, or a fraction, so if I have something like this, bracket 1/2 x all squared, in the bracket, okay, this one here is smaller than 1. This is a horizontal stretch. And if you want to figure out how big of a compression or how big a stretch is you take this number and you take its reciprocal. So 3 becomes 1/3. So this is a horizontal compression of 1/3. Please don't tell me it's a horizontal stretch of a third. The third is right. It's a compression though. It gets tighter. Okay, so if we go back to our video, or to our Desmos here, that is compressed. Now if I had to put a third in here, let's see if I can put a fraction here. 1 divided by, or a half, I think I had. 1/2, you notice now this is what we call a horizontal stretch of 2. So flip the 1/2 into 2 over 1, and now it is pulled over. See this point here? It's pulled over. This point here is 3.17-ish, and double that is 6.31. So I pulled this over. I take this point here, it's 2.77, double that, somewhere around 5.5. Take this point here, pull it out here, I end up here twice as far. So if it's on the bracket, once again, if it's on the X, it's horizontal. And again, horizontal stuff tends to be the opposite. When I had something in the bracket, so if we go back to our parabola in the first place, our basic parabola here, if I can I do this? Well, let me do this. Let me see. If I just had plain old X here, get rid of the blue one, and I put plus 2 in here, what's going to happen is I'm going to move left 2, right? I have a positive 2 here, but I got to change this sign when I pull it out, and I've moved to the left 2. Now, same with a horizontal compression and stretch. When I put a big number in front of it, so I've put a 6 in front of it, instead of, you think, okay, so it'll be 6 times as big, but it's not, it's 1/6 as big. So horizontally, it's 1/6 as big. It's a horizontal compression of 1/6. If I put a small number or a decimal, like 0.2, okay, 0.2 is the same as 1/5, so it gets confusing. Maybe you don't want to get confused with the fractions and decimals. 1/5 is stretch 5 times as big horizontally. So maybe that's how I personally think of it. Horizontal stuff in the bracket, counterintuitive. Hopefully that makes sense.